This is Edexcel A-level Further Maths 2021 Pure Core Paper 1. This is a follow-on to the video I did previously, which was 30 minutes of looking through every single question, making some preliminary notes and thinking about the questions. Basically familiarizing myself with the whole task at hand. I've got an hour and a half. I've got 75 marks worth that I want to try to pick up as many as possible. And the most effective way to do that is to get to the point where I can flick through and say, oh yeah, this one, I know what it's about. This one, I know what it's about. This one, it's going to be a quick one. This one is going to be a bit weird in the middle, but hopefully after that, it'll have a nice payoff. There are things I could jump into straight away. So for instance, question 4, I might jump into part 3 because it seems to be unrelated to the previous 2 parts. What I want to show now, for anyone who's curious, just for the sake of seeing how quickly this can be done once you've already gone through the initial method, is see if I can do these questions within the remaining 1 hour that I would have had in an exam situation. Be a little different because I'm going to be talking through it and I'm going to be having to type stuff and scribble things on the screen instead of on paper, but still, it's probably roughly comparable. And I'm going to jump into question 4. So I'm coming down to my notes that I made on question 4, and I'm going to write down what the answer is probably looking for that first part. It's asking me whether I'm allowed to do certain things with matrices. Is it possible to evaluate AB? Yes. AB is valid since A has the same number of columns as B has rows. I've already drawn myself a little mock-up here so I can see that the number of rows in B needs to correspond to the columns in A. A plus B is not valid since to add, both matrices must have identical numbers of rows and columns to one another. 2 marks straight away. The second part, I'm going to skip for now, but the third part I'm going to look at. So first of all, we've got a big, scary looking matrix, but I've already established for myself that it doesn't look much like the ones that I might have found in the formula book. If you look down at the formula book, they do give some matrix transformations. They give the 2-dimensional ones. They do not provide the 3-dimensional matrix transformations. But regardless, the ones that we would generate for ourselves from these, the one we're looking at here has elements from the reflection matrix, elements from the rotation matrix, but it's neither of them. It's some weird mixture of the two. What I'm interested in is when this is singular. And the fact that it's 4 marks means there's probably even more to this than just finding the determinant. There'll be a little bit of a messy equation to solve at the end, but I feel like that's a decent thing to get stuck into early. So I want the determinant of this matrix. And the easiest way to do that is to take each term from the top row, use alternating signs. So I'm going to have 1 multiplied by something minus 1 multiplied by something plus 1 multiplied by something. And the somethings are all going to be determinants of matrices. They will be 2 by 2 matrices. And what I care about is not the matrix itself, but rather its determinant. And in each case, the determinant I'm interested in will correspond to whatever terms are left over when I consider, say, this term. I'm looking at the matrix formed by sine theta, cos theta, cos 2 theta, sine 2 theta. This next one, I can make my life a little bit easier because I'll have 0 times this, take away 0 times this, so that's just nothing at all. And this next one, same kind of situation. So we end up with zeros there and there, and it boils down to simply sine theta times sine 2 theta minus cos theta times cos 2 theta. And I want to know when that determinant is 0. So the matrix I'm interested in is singular when the determinant is 0. And this reminds me of something which is in the normal A-level maths formula book. So let's check that out. If we take a quick look at the trig, we have sine A cos B plus cos A sine B, or sine A cos B minus cos A sine B. This is precisely the formula for sine of theta minus 2 theta. In other words, it's sine of minus theta. That makes my life a whole lot easier. I don't want to go the other direction and turn sine 2 theta into 2 sine theta cos theta and turn this into something involving that, because I'll get some awkward looking polynomial. But the fact that we had, wait a minute, I've seen the wrong one, sine, cos, I need to be looking at cos A plus or minus B. What I have here is the negative of cos theta cos 2 theta minus sine theta sine 2 theta. And the negative of that is 0, so that thing is 0, and that thing happens to be cos of theta plus 2 theta. And they've asked me in the question to deal with a situation where theta is between 0 and pi. So when is cos theta equal to 0? Well, that happens at pi by 2. We have 3 theta. So 3 theta must be equal to pi by 2. Or there's additional solutions, and I should at least find one of them. 3 pi by 2 is going to be the next one. That makes theta equal to pi by 6, or 3 pi by 6, which is pi by 2. We could go further, but if I add pi to this, I'm going to get to 5 pi by 2. And when I divide by 3, that gives me 5 pi by 6. Yeah, turns out I want that one as well. 5 pi by 2, which gives me 5 pi by 6. You can write out more carefully if you like. From 0 to pi means I need to consider all possibilities from 0 to 3 pi for 3 theta. And that should give me all of the ones I want. It's probably not worth going back, subbing them in to check them, but you could do if you had the time. So for now, I'm going to leave that question behind, but I'm going to remind myself here that I have a little more to do on that one. I'm going to see what other low-hanging fruit I have that I can work with. I like the idea of trying this one because the integral at least looks like it should be fairly quick. The reason they give you 3 marks is because you're dealing with a function where you have an infinite limit, but that doesn't necessarily mean it's going to be super tricky. So for the first part, I want to consider the integral from 1 to t of 2 e to the minus a half x dx, and that immediately is going to get evaluated. E to the minus a half x integrates to e to the minus a half x divided by minus a half, which means I'm multiplying by minus 2. I already have a 2 in front, so that becomes minus 4. And minus 4, in fact, can live outside those brackets. I need to evaluate those brackets between 1 and t. I'm going to get e to the power of minus t over 2. Take away e to the power of minus a half. Then I can just say as t tends to infinity, the integral, which I'll call I, tends to, and it should be clear what's going on. If t gets bigger and bigger, we get e to the power of negative a massive number. So we get minus 4 lots of something which is approaching 0, because it's negative exponent for the positive base, e to the power of a large negative gets you a very, very small number. And inside we'll just therefore have minus e to the minus a half, which is 4 e to the minus half, which you could also write as 4 over root e if you prefer. So that's my first 3 marks. I'm going to carry on because I'm familiar with this. I know where this is going. The mean value of the function, they want me to evaluate this. So I'm going to write out what my integral would need to be. 1 over 24, because I'm going to be integrating over the whole 24 hours. What I'm integrating is 8 minus 5 sine pi by 12t minus cos pi by 6t dt. And I'm not too worried by this because everything in that integral looks pretty straightforward. Again, the marks are given for recognizing what to do with the mean value of a function rather than giving you a horrible integration to have to work with. So 8 becomes 8t, sine integrates to negative cos, so I'm going to get a plus 5 cos pi by 12t stays the same, the frequency is going to remain the same, but we need to divide by the derivative of pi by 12t. So we're multiplying by pi by 12, multiplying by 12 over pi, that's where we get 60 over pi from. And then similar thing will happen here, but cos integrates to sine, so it still remains negative pi by 6t, and then we'll have 6 over pi in front. We still need to evaluate all of that between 0 and 24. And it's a show that question, so it's not enough just to jump ahead. We have to demonstrate that this is equal to 8. On the other hand, if we play fast and loose with our calculations, as long as we get the number 8, we can be fairly confident we've done the right kinds of things. So for starters, we should have 8 times 24, which I'm going to double check to make sure I don't make any silly mistakes on. 8 24s should be the same as 16 12, so 192 plus 60 over pi, and cos of, well, this will be quite nice, 24 times pi by 12 is just 2 pi. Cos of 2 pi is 1. And 24 divided by 6 is 4. Sine of 4 pi is 0, so I don't even need to do that second bracket. The third term rather, the second trig term. When I substitute in 0, sine of 0 still gives me 0. Cos of 0 is going to give me 1. 8 times 0 is 0, so I get 60 over pi. And reassuringly, anything messy involving pi sorts itself out. In fact, it's worth noticing that the 192 that I got by doing 8 times 24, if I'd been a little lazier, it would have sorted itself out. Because 8 times 24 divided by 24, I can do in my head. Now the adding of 60 over pi and the taking away of 60 over pi cancel out, so I can be sure that that's the right answer. And that's my proof for that bit. Given that the actual mean air temperature was higher than 8 degrees, explain how the model could be refined. Now for this, it just comes down to coming up with something suitably creative that demonstrates that you understand what's going on with the subtleties associated with modeling real life with mathematics. So have a think about it. If nothing suddenly springs to mind, then come back to it later and leave it as a note to yourself to come back to. I am going to skim ahead and see what else is good. I like the idea of doing maybe the vectors question because it looks like, although it's not a huge number of marks, it's going to be a fairly quick one, I think, for a vectors question to get through. Just going to be a little careful with that final part where we're working out the distance from a point to a plane. So to remind myself, they've said you need to demonstrate that a particular vector is normal to the plane. So I'm just going to start with that. I'm going to use 2, 3, minus 4. I'm going to dot it with each of the direction vectors in turn. Minus 1, 2, 1 equals minus 2 plus 6 minus 4 is 0. And it's a good idea to write this out, even if you can see it's 0, just to be on the safe side. So you can show the examiner you know exactly what you're doing, what you expected. 2, 0, 1 is the other direction vector. That's 4 and nothing minus 4. Dot product of 0 implies vectors are perpendicular. First 2 marks done. Hence find a Cartesian equation. Well, I'm going to use what I was describing up here. 2x plus 3y minus 4z equals, and then I'll get this dot product. 6 add 9 minus 8. 9 minus 8 is 1. 6 add 9 minus 8 must be 7. And I could then check if I want to be on the safe side. I take a point that I know is on the plane. Now I might use the same point, but just if I want to be really sure, I pick a different point. Maybe I set lambda equal to 1 and mu equal to 0 and see what I get. So I'll have the point 2, 5, 3. And that's going to give me 4 and 15 minus 12, which is 7. This bit you might even do in your head. It's not necessarily something you need to write down, but it confirms for me that I've got the equation correct. And now we get onto the meaty part of the question. We have a point. Point A, I'm going to get the general point from the line. So 4 plus t minus 5 plus 6t and 2 minus 3t. That describes for me a general point on the line. And I'm told that the shortest distance from that point to the plane is 2 root 29. Using the unit normal, I need to get the unit normal for that. So I already know that 2, 3 minus 4 is a valid normal. I just need to divide it by its own magnitude. And 2, 3, and 4 give sizes, when I square them, 4, 9, and 16, which is 29. Oh, there's that root 29 that's going to come in handy, I'm sure. That's the unit normal. Vector from any point on the plane to the point in question. So what I need to do is this vector minus a point in the plane. 3 through 2 seems like a sensible choice. So I'm going to end up with this minus 3, this minus 3, and this minus 2. Projected onto the unit normal. So 1 plus t minus 8 plus 6t minus 3t projected onto 2, 3 minus 4 just means dotted with it. The 1 over root 29 needs to be there, but it doesn't need to be inside this vector. Perfectly at liberty to leave it out in the cold. And I happen to know that that distance is 2 root 29. The one extra thing I've got to remember in here, like I said when I first went through this and made my preliminary notes, is that chances are I'll get to a point where I have the magnitude of something. The size of this projection is 2 root 29. I'm expecting 2 different points, one on each side. So now I'm going to make that dot product, 2 plus 2t minus 24 plus 18t plus 12t. Multiplying both sides by root 29 gives 2 times 29, or 58. But it's the size of this that gives 58. And when I simplify that, I'll end up with a minus 22. And then my t's, I've got 18 of them, 12 of them, that makes 30. 32t minus 22 is 58. So I could simplify a little further and call it 16t minus 11 is 29. But the alternative version is 11 minus 16t is 29. You could also put the sign change on the other side if you prefer. But I get t is either 29 add 11 over 16 or 11 minus 29, which is going to be 29 take 11 is 18, so minus 18 over 16. In both cases, I should probably simplify, if for nothing else than my own sake. 40 is 8 fives, 16 is 2 fives. This one will go to 9 over 8. It's negative. And finally, the possible coordinates of A, I'm going to go back to where I had A defined. These are the coordinates of A. So I can think of that as vector OA. Putting 5 over 2. Everywhere we see that, 5 over 2 times 6 is 5 times 6 over 2. 15 over 2. So 8 and 5, 13 over 2, minus 5 and 15 is 10, and 4 minus 15 is minus 11. And then t equals minus 9/8. It's going to give me a different result. Again, we just substitute in our value of t. In this case, we're adding 27 over 8. Here we are taking away 54 over 8. Here we are taking away 9 over 8. And we simplify. 32 eighths minus 9 eighths is 23 eighths. 40 and 54 is 94, so negative 94 over 8. And 16 and 27 makes 43. Might be tempted to do that on a calculator to make sure I'm doing things correctly, but I'm reasonably happy with those numbers. It might be nice to simplify some. So for instance, 94 over 8. Be polite to the examiner to write it as 47 over 4 perhaps, but there is value to having everything over the same denominator, I suppose, arguably. So that's my coordinates of A, and I've got a question ticked off. Question 7 is done, and I'm reasonably confident that my method is sensible for it. And the other one I'd like to get stuck into early before I get too far into the exam is this one, because it's going to take some thought, may take a bit of time, but you know, I've got 9 marks worth. I'm happy to spend a few minutes on this. So let's think this through carefully. I don't need to spend so long getting my head around what's happening, because I did quite a bit of that when I first skimmed through the question at the beginning. I can see, for instance, we've got 30 litres at the beginning, 10 litres of red, 20 litres of blue, and initially red is added at 2 litres a second, blue is added at 1 litre a second, and a mixture is removed at 3 litres per second. R is the amount of red. I want to know how quickly the amount of red is changing. It's equal to the amount of red being added, which is going to be 2 litres per second. And then we need to subtract how much is leaking out. And that's going to be the concentration multiplied by the amount that's leaking out, which is 3 litres per second. Now we need to work out what the concentration is. The concentration is just the amount of red divided by the volume. And the volume itself is fixed. So that's quite convenient. It holds a mixture of 10 litres of red and 20 litres of blue. And every second the volume increases by 3 but also decreases by 3. So the volume is fixed at 30. And that means this becomes a bit nicer. R over V is R over 30. So dr by dt is equal to 2 minus R over 30 times 3, which is 2 minus R over 10. So the alpha in their equation is 10, and everything else matches what they've got. So I'm happy that I've done that correctly. By solving the differential equation, determine how long it will take for the mixture of paint to contain equal amounts of red and blue. In other words, when our constantly 30 litres of paint has 15 of those litres being red. So this is what the question is asking me. Now I can go ahead and solve my equation. So let's write it out and think about what it says. dr by dt is equal to 2 minus r over 10. R only appears in one place, and there are no t values in here. So I am tempted to do this using straightforward A-level maths content methods. dr by dt is equal to, I'm going to put the right hand side together. So I'm going to multiply and call it 20 minus r all over 10. 1 over 20 minus r on the left with a dr is equal to a tenth on the right with a dt. Because this is a variable separable differential equation. There's nothing stopping you from doing it using other methods, but you'll find they're a little bit overkill. This one should be minus ln of 20 minus r, because 20 minus r differentiates to negative 1, so I can pull out a negative 1, and the top is the derivative of the bottom. On the right hand side, we have 1 over 10th t, because we're integrating with respect to t, but don't forget the plus c. That's going to be particularly important, and we're going to use it when we start looking back at how much we had of things at the beginning. In particular, at t equals 0, we already had some red paint. It said that we got 10 litres of red paint right at the start. So often what I will do at this point is substitute that value in before I try rearranging. 20 minus 10 is 10, so ln of 10, or minus ln 10 on the left, and c on the right. So I've immediately got the value of c without having to do much messing around. Now I'm going to rewrite this as ln 20 minus, that's not what I want to do. I'm interested in when r is 15, so again, I'm not going to bother rearranging things until I've put numbers in. Minus ln of 20 minus 15 is just ln 5 with a minus sign, and then that's 1 over 10t minus ln 10. So let's rearrange things. We have a 10th t equals ln 10 minus ln 5 if I switch things around. But log laws tell me I can do 10 divided by 5, and ln of that is the same as ln 10 minus ln 5. So t is 10 ln 2, which I can then find an approximation for on the calculator. ln 2 is 0.693, so we have about 6.93. And I just want to double check the units for my time. T seconds after the color, so it's going to be seconds. Give your answer to the nearest second. It's always worth rereading these. 6.93, I don't want that, equals 7 seconds to the nearest second. You don't want to do 6 marks worth of differential equations questions and then lose one of them just through a rounding error. It actually takes 9 seconds to consist of equal amounts. That's reassuring. It's not far off my 7 seconds, but it is slightly different. Use the information to evaluate the model. I'm going to say something along the lines of, the model is reasonable, but not hugely accurate. Presumably, this is due to the impractical assumption that perfect mixing takes place. That's the key thing with any of these concentration type questions. They assume that because the paint is stirred continuously, each color is instantly dispersed evenly throughout the container. In reality, if you pour paint in from above and you drain from below, it's going to take some time for that to filter through. So you won't be losing red paint quite as quickly, which is why it takes longer. So that fits, it makes sense. And that's all of question 8. So we've done a couple of questions in full. And if you're keeping track of time, we're somewhere around 2/3 of the way through the hour and a half. This one is a meaty question with 6 marks followed by 5 marks. It's one that is probably worth doing for the number of marks. It's worth getting stuck into and making headway with. So I'm going to come into question 9 next. And I'm confident that there's some other quicker questions I can do when I'm perhaps feeling a little more tight for time that I can do relatively efficiently still pick up some quick marks. However, before I do question 9, thinking of quick marks, there is a question earlier on that I remember seeing that I would like to jump to. Because this one, the cubic equation, is also 6 marks, and it should be a fairly nice one to work with. I already had a look at this earlier on, so I've made a few quick notes, and I already know which substitution I want to do. So I'm just going to dive in and do that substitution, pick up my 6 marks, and see how rapidly I can get through that one. So I've already jotted down VET's results in case I want to use that, but I've already made a start here. I know that what I'm interested in is this. The sneaky thing here is that they've already given me the other cubic equation, at least partially, with an unknown value c. And I need to work with both. But at least I know that if I substitute in x add 1 over 4 to the second of these, I'm going to need to cube that, take away 9 lots of x add 1 over 4 squared, and take away 97 lots of x add 1 over 4. Add c. That should have roots of... I've done this completely the other way around. The way the W1 is created from the original. So I want a lots of x add 1 over 4 cubed plus b lots of x add 1 over 4 squared minus 19 lots of x add 1 over 4 minus b. And to make my life easier, I'm actually going to multiply through by 64. I'll do that after I've sorted this out. X cubed add 3x squared add 3x add 1. That's nice and quick. B over 16, and then x squared add 2x add 1. Taking away 19 over 4 lots of x add 1, and take away b. To make things a little bit nicer, I'm going to multiply through by 64. And I'm also going to start collecting terms. The x cubed terms are the easiest. There's only one of them at the beginning. And then x squared terms, I'll have 3a, and take care here because this is going to turn into 4 lots of b over 64. And that'll be 19 times 16 over 64 when I get to that part. And then the minus b is also going to be multiplied by 64. So if I'm going to divide through by 64, if I'm going to multiply through by 64, I should keep track of my 64s carefully if I want to be doing two things at once. So I have 3a x squareds from the first bracket, but I have 4b x squareds from the second bracket, and I'm losing 19 16s, or 304 x's. Wait, that's x's, I don't care about those yet. We have 3a x's plus 8b x's minus 304 x's, and then finally minus 64b equals 0. And that, I've been told, is equivalent to w cubed minus 9w squared minus 97w plus c equals 0. So this is a little weirder than it initially looked when I first glanced at it. It's not a run-of-the-mill, here's a complete cubic, find the corresponding cubic. We've got to find the unknowns that are hiding within. But we can do some comparisons. So the first thing I want to notice is, for instance, that c and minus 64b, they could be the same. I can also immediately identify a. A's got to be 1. If ax cubed and w cubed are going to be the same, now I've made this conversion, then a has to be 1. And that means that 3a plus 4b is just 3 plus 4b, and that's got to be equal to minus 9. That means 4b is minus 12, and b must therefore be minus 3. Then I get to the next bit, the x terms. In fact, if I know that b is minus 3, it means c must be minus 64 times minus 3, so that's going to be minus 192. Sorry, positive 192. And just for completeness, I can even check this third bit here, which I don't think I need, but I can try it anyway. 3, add 8b, take 304. Is it equal to minus 97? And it's a good job I checked this bit, because the assumptions I'm making are that this has not been scaled. 3 minus 24 minus 304 is not what I was expecting, minus 97. But I bet it's going to be a reasonably nice. It's not a nice multiple of it at all. I tell you what's happening. That is the first thing. The thing I can be sure about with this is I can't necessarily say that a is 1, but what I can do is divide all of this through by a. And then this will be valid for a certain value of a and corresponding values of b and of c. So now I can go back through. I might have some different things to work out. So I can say that 3 plus 4b over a has to be equal to minus 9, and that 3 plus 8b over a minus 304 over a has to be equal to minus 97. I can solve those simultaneously. They're not very nice, but they're solvable. For a start, I think the fact that I've got b over a in here is going to be helpful. So let's see. We'll have b over a is equal to minus 12 over 4, which is minus 3. And that means down here I can do 3 plus, in fact even better, if 3 plus 4b over a is minus 9, then 6 plus 8b over a is minus 18, and 8b over a is therefore minus 24. So 3 minus 24 minus 304 over a is equal to minus 97. I can find the value of a directly from that. So back to the trusty calculator. Minus 97 plus 24 minus 3, and then I want to divide that by 304, deal with the minus sign. I think that means a is 4. Let me double check that that actually works, because I did a lot of messing around and rearranging without writing things down. 3 minus 24 minus 304 over 4 minus 97. That's nice. So now I've got a, and it's a nice-ish number. I now know that b is minus 12, because it's b over a was minus 3. And from that I can get c, because I already know that minus 64 b over a is equal to c, which is minus 8 lots of 8b over a, which I already said was minus 24. I can double check. b is minus 12, so this is going to be positive. 12 times 64 divided by 4 is 12. That doesn't look like 24. 64 times 12 divided by 4, 192, the negatives cancel. So now I'm saying C is 192. And that took a little longer than I was expecting, so maybe it's a good idea that I jumped in before too much longer. But I have now found the value of A, the value of B, and the value of C. And I could, if I wanted, go back, put this in a calculator, but that usually takes longer than it's worth spending, in my experience. So we've got a Maclaurin series question that I might jump back to now. I have high hopes that this will be a little more sensible and straightforward, because I don't think it's going to be as nasty as it seems. The formula book for Further Maths has the McLaurin series expansions. You might already know some of these off by heart, but this one, notice it's valid for all x, but it's centered around 0, so it's going to be most accurate close to 0. It's going to have even powers. I think I might have said earlier odd powers of x, but this is why we take the formula book. Cos is 1 minus x squared over 2 factorial, etc. So I can use 1 minus x over 3 squared over 2 factorial plus x over 3 to the 4 over 4 factorial. That can represent for me cos of x over 3, and if I square it, I'll get cos squared of x over 3. Now, although there are 3 terms and I'm squaring it, I don't need to collect all 9 terms. I need the constant times a constant, need a few other bits, so it's worth simplifying this. X squared over 9 over 2, so it's going to be x squared over 18, and then this is x to the 4 divided by 81 and divided by 24. So that's 1944. Luckily, I'm not going to need much from that one because I only care about terms up to and including the x to the 4 term. But I'll need the constants, 1 times 1. I'll need 1 times x squared over 18 twice, so x squared over 9 altogether. I'm going to get an x to the 4 term from a couple of places. One of them is going to be x squared over 18 times x squared over 18, x to the 4 over 324. And the other places are going to be 1 times x to the 4 over 1944 and another 1 times x to the 4 over 1944, which will give me x to the 4 over 972. If I add that to my 1 over 18 squared, I get 1 over 243. So I can jump straight to that. I've got the first bit of the question. Give each term in its simplest form. Done. That's part A completed. And I can move on to part B, which is using your answer to find an approximation. So this means I'll have 1 over x times my expression the integral they've given me is approximately equal to this integral, and this can be evaluated quite quickly. But before I evaluate it, I need to deal with that 1 over x. I cannot just integrate this nice quartic and pretend that this isn't there. And I don't want to use something like parts, but what I can do is divide through by x. I can incorporate that 1 over x term, and it's going to affect each of these powers. So 1 times 1 over x is 1 over x. X squared over 9 times 1 over x is x over 9, and so on. And that allows me to turn it into something that I can integrate fairly nicely. I'll get ln of x minus x squared over 2 over 9 plus x to the 4 over 972 and I need to be integrating that between the limits given. Be a little bit of a mess, but they've only asked for 5 decimal places, so I throw it in the calculator. Ln of, well, let's make this a bit easier for ourselves. Let's store a value. There's pi by 6. I'm going to store it as x, and I'm going to work out ln of x minus x squared over 18 plus x to the 4 over 972. That's the first number. I'm going to store that as a. And then I'm going to do the same kind of thing again, but this time I'm going to have pi by 2, store that as x, and the same thing, ln x minus x squared over 18 plus x to the 4 over 972. Store that one as b. Then I will subtract 1 from the other. So all of this happens on a calculator and I get 0.98295. And even if they hadn't asked me to calculate the original on the calculator, I think I would have done anyway, but they give me a mark for that just to see what we get. So with the calculator, I need to evaluate the proper integral there, which is 1 over x, then in brackets, multiplied by, some more brackets for this bit, we've got to be careful, we have cos of x over 3. Get in the habit of double checking that you're in radians as soon as you start doing trig in calculus. That cos of x over 3 is going in a bracket, so I can square that as well. And then my limits are pi by 6 and pi by 2. Reassuringly, it's close, but not massively close, which is exactly what we were hoping for. 0.98280. Assuming the calculator's answer is accurate to 5 decimal places, comment on the accuracy of the approximation found in part B. They haven't asked us to work out the actual accuracy as a percentage, but if you're curious, you can do 0.98295 divided by 0.98280, and you can turn that into, there you go, 0.015%. So the approximation is accurate to 3 decimal places, but not to 5. The series expansion is centered 0, and pi by 2 is not sufficiently close to 0 to get an extremely good approximation. That might be a little more detail than they're looking for, but better safe than sorry. Okay, I'm going to go back up to the matrices chapter that we saw at the beginning. I think that'll be a nice, easy one. Once you're getting bogged down in a paper, flicking back to a question you think will be a little more manageable is always a good idea. If we remember, the formula book for Further Maths has this anti-clockwise rotation matrix, which is worth jotting down for yourself at this point, because they're describing a rotation within the question. So I already know I'm going to be interested in something that involves cos minus sine, sine cos. That's an anti-clockwise rotation by theta degrees. They've said we have an anti-clockwise rotation by theta. In other words, precisely what I've just mentioned. Cos minus sine, sine cos. So that I'm going to use the letter Q for the transformation. Transformation P followed by the transformation Q is represented by this. Transformation P, I already mentioned when I started making my notes for this question. So I've got an enlargement vector, enlargement matrix there. They've said that if you apply P followed by Q, in other words, you apply P to some stuff, and then you come along and you apply Q, it's like you're doing a function of a function. F of g of x is written as fg of x. Q of P of a vector is qp. So we need to multiply them in that order. Here's my first matrix, and here's my second matrix. And they both look a little confusing, but don't forget, a rotation matrix has a determinant of 1. You can check cos squared minus sine squared is always 1. So the size of this one is 1, and that gives us a clue as to the size of this one. because this is exactly k times the identity matrix, and this one has a determinant of k squared. So we can make use of that when we look at m. In fact, I can look at the determinant of m straight away and get minus 4 times minus 4 is 16. Take away the negative of 16 times 3. In other words, the determinant is 64. That means k is either 8 or negative 8. But it says k is greater than 0, so k is 8. And that means that when I write down my matrix, I can make use of that, and it'll make it a lot easier to work out what the value of theta would be, because I already know the value of k. So if I multiply these two matrices together, I'm going to get, not quite this, but I'm going to have k times cos and then nothing. For the next bit, nothing, and then minus k times sine theta. So minus k sine theta will go there. This next one comes from sine times k and nothing else. And the last one comes from sine times nothing, cos times k. If you look carefully, you'll notice I could have saved myself a bit of time. This is the same matrix, cos minus sine, sine cos, just with a k put in front. And that's because the k001 is the identity matrix. So that would have been a fairly obvious one. Now I know that 8 cos theta is actually equal to minus 4. I'm not going to treat this as a matrix anymore. I'm going to treat it as a bunch of related equations. 4 root 3 is equal to 8 sine theta and the corresponding results I can just confirm for myself that minus 8 sine theta gives minus 4 root 3 and that 8 cos theta is minus 4, so that's consistent at least. Now I know that cos theta has to be minus a half and sine theta has to be root 3 over 2. Just be a little wary with this, because the obvious answer to inverse sine of root 3 over 2, which you might even know without looking at the calculator, is going to be 60 degrees or pi by 3. However, that solution doesn't work. If you do cos of that answer, you get half, not minus a half. So you need to look at both. If you do inverse cos of minus a half, you'll get 2/3 pi. You could say to yourself, well, maybe sine of 2/3 pi is okay. And there you go. So you can check both, and you end up with 2 pi by 3. So watch out when one's negative and the other isn't. Test for additional solutions in each case until you find one that fits both. It says the smallest value of theta. And it also says that it's been rotated anti-clockwise, so it doesn't make sense to think of theta as being negative. This is the smallest value it can be. It must have been rotated by 120 degrees. Next, a square S has vertices at these points. The square is transformed. Determine the area of S. Now, I would have been tempted to jump straight in and transform the square. You can think in terms of the vector 0, 0, followed by, alongside that one, another vector with a minus a, and so on. And you can effectively make yourself a matrix where every column is another vector, and then you can just apply to the front of that the matrix that represents the transformation. However, that's not what they're asking for here. All we need to do is visualize this square. 0, 0 to a minus a means along a and down a, and then to the point 2a, 0, that means along 2a and not down at all, and then AA. It's actually a weird diagonal kind of square, and the length of the sides is an easy enough one to work out once you recognize that. It's going to be a root 2. So the area of the square before it's transformed which you can probably get from a diagram if you can't visualize it in your head, is just a root 2 times a root 2, so 2a squared. Another way that's quite nice to do this is to think about the square, the bounding box for that square, which is actually vertical and horizontal. So the one they're describing is a square that kind of looks like this, but the bounding box for that square has exactly twice the area. And that box is 2a by 2a, which is 4a squared. And therefore ours must be 2a squared. Now, why is that all that I need? Because it says find the area of the transformed square, and the transformed square will have area increased by the determinant of the transformation matrix. So I just need to take my 2a squared and multiply it by the determinant of the transformation matrix, which, if you remember, the transformation matrix involved a rotation, which doesn't change the size, and an enlargement by scale factor 8. But that was scale factor 8 in the x direction and in the y direction. And if you remember up here, that's why we got a determinant of 64. The determinant is the area scale factor. So we get 128 a squared. Now, just to recap, we've whizzed through and we've looked at these. We've completed the first few of these questions. We've not done question 4. We've completed 5. I believe we did most of 5. We didn't look at the last part of 5, but we could go back and see if we can fill in some oddments. What we've not yet looked at that will be worth spending some time on is question 6. Because there's a lot in this question, but it should be, for the most part, routine stuff that you've worked with. Second order, homogeneous differential equations. So let's jump in and give it a try, see if we can pick up those marks nice and quickly. For a start, it says determine the value of k. Well, they've told us things to do with not just the initial displacement, but also the initial velocity and the initial acceleration. So we can say at t equals 0, we should have 5k times the acceleration of 13.6 plus 2k times the velocity, which is 0, plus 17 times the displacement, which is minus 20. We're told that equals 0. So this is actually quite a nice one to start with. Just a linear equation, 5 times 13.6 is 68. So we have 68k, and notice that 17 times 20 is also going to be a nice multiple of that. So if we divide 17 times 20 by 68, we get k. Not bad for 2 marks. Determine the particular solution. This is where we jump in and start doing what we're used to. 25 times m squared, and then 2 times k will be 10 times m, and 17. That's the auxiliary equation. And I'm expecting this to have complex roots. We can solve directly on the calculator. So we just need to put in 25, 10, and 17, minus 1 plus or minus 4i all over 5. So the roots are minus 1, I'll write it like this, minus a fifth, plus or minus 4/5 I. Therefore, the general solution we can construct straight away. It's going to be x equals e to the minus a fifth t a cos 4/5 t plus b sine 4/5 t. And we've already picked up a bunch of the marks for getting the general solution. They want the particular solution, so we have a little more work to do. We have to say at t equals 0, x equals minus 20. So we have to substitute that in. Minus 20 is going to be equal to e to the 0 is 1, so we're left with just the trig. When t is 0, sine of 0 is 0, so we're left with just a cos 0. But cos 0 is 1, so we've got a straight away. That's nice. How do we get b, however? That's not going to come out automatically. But remember, we've been given additional information. We were told the velocity is 0 when t is 0. So let's find the velocity, dx by dt. This will require me to differentiate this. And that's why there are 7 marks for this section. But I can be a little bit savvy. For a start, there will be exponential stuff involved. But because t is going to be 0 when I substitute in 0, I don't need to worry exactly about what the exponential stuff will be. I'm going to have e to the 0 cropping up. There'll be this stuff multiplied by the derivative of this, and then there'll be the derivative of this multiplied by this stuff. So you've got to be a little bit careful, but you can save yourself a bit of time by thinking about only the bits you care about. So e to the minus a fifth t multiplied by some stuff, and then minus a fifth e to the minus a fifth t multiplied by, and this will be where we differentiate these pieces. I only care about the bits that are actually going to have non-zero values when we sub in t equals 0. So for this version where it's not differentiated, where this one's not differentiated, the trig stuff will be differentiated. The cos bit is going to become sine, so I don't care about it. So I'll just call it 0 straight away. And the sine bit becomes, well, sine differentiates to cos, so we're going to get 4/5 b cos of 0, so 4/5 b. This is the bit where these terms are not differentiated, so we're going to get a times cos of 0 plus b times nothing. And remember, these pieces have also got a 0 in, so although I wrote them there so I could keep track of what I was doing for this part, I don't need them anymore. I get 4/5 of b minus 1/5 of a is equal to 0 because it said the velocity is 0 at the beginning. And that means, well, 4b minus a is 0, 4b must equal a. But a is minus 20, so b is minus 5. And for completeness, I want to actually write out the particular solution, so I make sure I get all the marks. A, I said, was minus 20, b minus 5. So there we go. Maybe we pull out a 5 from the whole thing, maybe even a minus 5. We can leave this bit written in slightly nicer form. 4 in front of that, and then just plus sine 4/15. Now the next bit should be nice ways to pick up extra marks as well. Hence find the vertical height 15 seconds after they've reached their lowest point. 15 seconds after they reach their lowest point. When will they reach their lowest point? When's the minimum of this going to occur? This will take a little more thought. And that laziness we had up here is going to come back to bite us, because actually it might be helpful to have an expression for the derivative. But it's their lowest point. Perhaps we can do something a bit cleverer. Oh yeah, hold on. At time t seconds after the torus reaches their lowest point, their vertical displacement is this. It's only 2 marks. I thought, are they expecting us to get stationary points? No, 15 seconds after they reach their lowest point just means t equals 15. So t equals 15. We can find the value of x, and x represents their vertical displacement above a point 30 meters above the river. We need the height, but that's just going to be using x, and then referring back to the model, doing some subtracting with 30 meters. So we throw that into a calculator and get some numbers. I'll have minus 5 times e to the power of minus a fifth of 15, in other words, minus 3, I want to multiply that by 4 times cos 4/5 of 15 is 4 threes plus sine of the same thing minus 0.70 something. And because that gives the vertical displacement from a point 30 meters above the river, just like x equals minus 20 was the initial point, they've moved up. 15 seconds later, they are close to the top, but we need to do 30 plus that because their initial height was 30. If we add that vertical displacement from there, we can get the height itself, which is 29.3 meters to 3 significant figures. Give a limitation of the model. Well, there's all sorts of things that can happen with a bungee jump that we've not modeled for. So the system will lose energy is one of the key things that's going to happen. Unfortunately, we can't include that one because I've just realized we've got, that's kind of built in. That's the e to the minus a fifth t. We've got exponential decay as time goes by. One thing that might happen is bungee jumper may move sideways as well as up and down. This is typically what happens. You start swinging sideways, your vertical kinetic energy gets translated into horizontal kinetic energy and you swing instead of bounce. So that's probably the main one. I don't know if they would allow things like air resistance and so on because that's potentially taken into account by this decaying motion that we see. Perhaps we say the model implies that the jumper will continue to move forever, just at lower and lower amplitudes. But again, that feels a bit unsatisfying because the exponential decay does imply that it's going to taper off significantly. So it still seems like a reasonable approach for a model. It does seem to imply, however, if you think about the long-term behavior, that x tends to 0. Which means that in the long run, the jumper ends up at, I don't know, I was thinking that might be the point on the bridge, but they've just said it's a fixed point 30 meters vertically above the river. In fact, that might well be the equilibrium point. They're dropped from, well, they have a zero velocity at that point. Sorry, zero velocity when they're 20 meters below that point, but they're accelerating upwards at that moment. So that must be possibly the lowest point they reach, or yeah, at t equals 0. So something like that will do for my limitation. Right, let's move on and pick out any other questions we've not yet done. We've done our vectors question. We've done the big meaty paint question. We've not yet done question 9, so that's going to be the next one we look at. Use a hyperbolic substitution. Well, this is where I check the formula book to see what will be the most sensible. The Further Maths formula book will give us various trig substitutions, all of the inverse trig and inverse hyperbolics. So down here we've got 1 minus x squared and in a square root, but then x squared minus 1 arc cosh, which makes sense. So if that's going to give me arc cosh, which it also shows here, that means that I want to say something like let x equal cosh u. That gives dx by du equal to sine u. And my integral is going to become Well, x squared is cosh squared u. On the bottom, we've got the square root of cosh squared u minus 1. This is a point where on my du also has a shine u du gets swapped out for dx. But I would look back at the formula book to remind myself of the hyperbolic identities. Hyperbolic functions obey these rules. Cosh squared minus 1 is shine squared x. As we might have suspected, that makes a lot of sense. So our integral becomes something a bit nicer straight away. There's a cosh squared u on the top. There's a shine u here, but the square root of shine squared u is also shine u, so that disappears. We get the integral of cosh squared u du. Slight conundrum, cosh squared u, bit of an awkward thing to work with because it's cosh squared. So where do we go from there? Well, if we look in the formula book, there's a couple of different things we can think about. If we look here, we can see some clues as to what kind of thing we might end up with. There's an arc cosh that seems to appear, but also x times the square root of x minus 1. So, I'm thinking a substitution. I'm thinking if we had cos squared, we'd use the double angle for cos. Since we've got cosh squared, maybe we use the double angle for cosh. But I'm also in two minds about that because I don't think it's a huge amount of work just to turn it all into exponentials. It just might be a little more awkward to turn it back into inverse cosh if I do that. So let's see if we can do it with identities first, but if in doubt, I'll go back and turn it into exponentials, which I could definitely integrate. It wouldn't be hard to square cosh of u from first principles. But let's start with double angles, because I've got over here a double angle formula for cosh 2x, so I'll turn that into cosh 2u. That's cosh squared u minus, plus shine squared u, but shine squared u is equal to cosh squared u minus 1. So I can just turn that into 2 cosh squared u minus 1. And I can go one step further by adding 1 to both sides of this, then dividing by 2. And now I start to see a little bit of where my integral is going, because I get a half cosh 2u for that bit, but I also have a separate half. And a half cosh 2u integrates to give a half of shine 2u divided by 2. The half integrates to half u, but don't forget what u is. It's arc cosh of x. So this awkward thing is going to need sorting out, but perhaps by looking at what I'm looking for in my solution, x and root x squared minus 1, x is just cosh u, and root x squared minus 1 is shine u. So the fact that I have shine 2u should be a bit of a clue. I can turn shine 2u into 2 shine u cosh u quite nicely. So this becomes, instead of a quarter, I'll have an eighth of, so I'll start with get it right, a half of shine u cosh u. That's a half u. Now shine, I already know, is the square root of x squared minus 1. We use that already to get to that first bit. Cosh u is x, and u itself is arc cosh of x. And then I'll remember, just before it's too late, to put my plus c on the end. They've got a plus k, I'll use a k as well. Oh, and they've pulled out the half. So if I also pull out the half, then we're being a little more thorough. Matches theirs a bit better now. Okay, so that's those 6 marks. We have another 5 waiting for us if we can do the next bit. So we want the integral from something. Now this is actually easier than it might seem. Where does this curve cut the x-axis? Cuts it when y is 0. That happens at 2 points. When x is 0 or when r cosh of x is 0. And r cosh actually has a form here. R cosh of x is 0 when x plus root x squared minus 1 is 1. Which means 1 minus x is equal to root x squared minus 1. And 1 minus x all squared is equal to x squared plus 1. It was easy. It's going to take a little more messing around. We can take away lots of things. It all reduces rather annoyingly down to x equals 0. So r cosh of 0 is 0. We could probably have done that on the calculator too. But it looks like this curve, although they've not drawn it accurately, should cross at 0 on the y-axis. So we want to integrate between 0 and 3. We want 4/15. I'll leave that out front, but it might come in handy later. There must be a reason they've done that. And then r cosh of x dx. And I already said when I looked at this question before that parts is probably going to be helpful. I'm going to differentiate r cosh x. I'm going to integrate the x bit. Now we have uv squared over 2 r cosh x minus the integral of v du by dx, which is, leave that half outside, x squared over root x squared minus 1. As predicted, it becomes what it is we're expecting. Got to be a little bit careful with this piece. So my original integral, maybe I'll call that j, because I've already got this one I. J is going to be 2/15 of the integral between 0 and 3, this stuff, which should look familiar to us. They did say use the result from the previous part, so I'm on the lookout for that. And that's precisely what this is. The previous part allowed me to calculate that particular integral. So I just need to sub in my numbers. 2/15, all of that stuff. Subbing in 3 gives me 3 times the square root of 3 squared minus 1. So 3 times root 8, that's going to be 6 root 2. And then there's an r cosh of 3 involved. Then I want to take away a nice boring nothing and a nothing. 2/5 of 6 root 2, 2/15, sorry, 6 root 2, I can divide by 3 to get 4 on the top and 5 on the bottom. So 4 root 2 over 5 plus 2/15 of r cosh 3. Now that should be a correct answer, and I'm going to look at what their form gives me in terms of the root 2. There's a minus 6 root 2 over 15, so in fact, it's close. It looks like there's more root 2's kicking around. So before I go too much further, I'm going to double check I've got my root 2 bits correct. This first bit here is x times root x squared minus 1. 3 squared minus 1, that's 8, that's 2 root 2, times 3 is 6 root 2. So there's definitely a 6 root 2 there. I need a half built in, which I don't think I've done yet, that 2/15. I forgot to build in the half. So it's not just 2/15 of all of that, it's 2/15 of half of all of that. So that's why it's worth checking before you go too much further. This is only going to give 2 root 2 over 5, or we stick with it in the form that they have it, 6 root 2 over 15. And we have 1/15 of arc cosh 3. I'm not concerned about the other bit. Remember, the formula book has a log version of arc cosh. So I can write this as 6 root 2 over 15 plus the 15th of ln. We have 3 plus root 3 squared minus 1. In other words, another one of those root 8s or 2 root 2. Check what asked for. 17. No idea where the 17 has come from. We have positive 6 root 2 over 15, which is worrying all on its own. Ah, I see what's happening. I think x greater than or equal to 1. 4/15 of x arc cosh x when x is greater than or equal to 1. Does that mean we should be integrating between 1 and 3? And it seems a little confusing because arc cosh of 1 let's look at the hyperbolic function. Arc cosh of 1 is 0. Oh, there you go. Arc cosh of 1 is 0. So x equals 1 is a valid solution for that. So having looked at the solution that they have, I can just go back and modify my limit and everything should get fixed. When we get down to here, we've got this piece that I put in bold. I need to subtract some other bits. I need to subtract properly what happens here. Not just 0, but when x is 1, we're going to have this result from before, which is 1 times nothing. So that bit disappears to nothing, even though x is 1. But r cosh of 1, which is also 0, so that just disappears anyway. Well, I may come back to that, but let's check back, see if there was anything else we left behind that we can pick up on at this point. Handful more marks that we might get before the end. This was the question involving exponentials. Explain how the model could be refined. If the actual mean temperature recorded on this day was higher than 8 degrees C, it's quite possible that because this model implies some kind of periodic behavior, there'll be fixed peaks and troughs. The pi by 12t, if you think about what that does over the course of 0 to 24 hours, it's going to give you a cyclical behavior, but it goes between 0 and 2 pi. This one goes between 0 and 4 pi. So it's going to give you some weird waves within waves. But one thing the model doesn't do predicts predictable maximum minimum temperatures throughout the day. Doesn't take into account any extremes, e.g. during midday. Something along those lines we'll probably do for that. Now, the other bit I've not looked at, which I would probably come back to at this point, instead of scratching my head with a question where I've missed something and I've probably got most of the method marks, I'll come back and I'll take a look at this question 4II that I missed off before. Can I determine these values? Luckily, there's lots of zeros, so although it looks daunting, I feel like I could quite comfortably sort things out in there. Remember, we have 3 by 3 matrix. The right hand side corresponds to essentially the identity matrix, just with some value lambda in place of the ones. And that can help me quite a bit because I can selectively choose the numbers I want to multiply together in order to find equations that are going to make my life a bit easier. So now I have 0, 5, 0, 2, 12, minus 1, minus 1, minus 11. So maybe I pick a row and a column that are going to give me a 0 on this side, but preferably one that involves an A or a B on this side. So let's start with this one. This is the second row, and if I go with the first column, it should correspond to the second row, first column here. So A times nothing. Oh dear, that's not going to help me. So let's go with anything where there's nothing there, it disappears. Ah well, we'll use it anyway, but we'll look at the third row. We'll have A times 5, nothing times 12, nothing times minus 11 has to be equal to lambda. Now maybe we can get a value for lambda by looking at the minus 5. Minus 5 times nothing plus 3 times 2 and a 1 times a minus 1. In other words, 5 is going to have to be equal to lambda. So now we have A. Then we look at B, so the third row and whichever. So we'll go with the second column so that we actually have an entry for that one. 5b plus 12a minus 11b has to be equal to lambda again. But now we know that lambda is 5, and we also know that a is 1. So that's going to help us out. We'll have minus 6b plus 12 ones is equal to 5. So minus 6b is equal to minus 7. B is minus 7 over 6. Now, A was a nicer number, so I'm a little suspicious of this one. So I'm going to double check that. I might try this third value just to be on the safe side here. That last one there we get by considering, I think we did that, 5 of those, 12 of those, minus 11 of those. I'm happy with that. That's the third row and the second column. Third row, second column, it should equal 0. So let's put that instead. It's not a surefire thing that if you get nasty numbers, the question is wrong, but it's usually an indication that it's worth double checking because mistakes creep in inevitably. If you are on the lookout and you're a bit suspicious, that's often no bad thing. So now I've got A, B, and lambda, and it wasn't too bad. And B just says hence deduce the inverse. So what I'm going to do now is divide through by lambda, and if lambda is 5, a fifth of this is the inverse matrix, because that matrix is what you would multiply this matrix by to get the identity matrix, which is the identity matrix multiplied by lambda is this, but this is what you get when you divide by lambda. So that is quite a nice end to the first section. And I did the third section already. I found the values of theta for which that is singular. So we're all good. Question 4. We've done pretty much every part of this. There were a couple of pieces that I got in a muddle with. I think all of the rest are done. This current talk through has taken an hour 30, and my previous initial read through I did in 30 minutes. So yes, that was 2 hours instead of the hour and a half you will have. Remember, you'll have less time nattering to people on a video, and you'll have more time writing things down. It'll be easier for you to flick back and forth between questions, because when you stop in the middle of question 4, you'll be writing in the pages relevant to question 4. So you can flick back and forth a little bit more like that. Even if you decide as you skim through for your first look, you're just going to take a very cursory glance and put stars next to the tricky looking questions and circle a few things that you notice. If you budget for yourself 10 minutes, 15 minutes, 20 minutes, whatever you feel comfortable with, give it a try with the next past paper and see how it works for you. And then see if it helps your method if you're working through and picking up the marks where you best can. If this year's paper is as difficult as people are saying it might be, then you shouldn't be going into the exam thinking, I'll do every question and get them all right. Even if that's a possibility for you, your best bet is to go in thinking, I'm going to get as many marks as I can in the time that I have, and then any extra time I have at the end, I'll go and pick up as many additional marks or check and verify the questions that I'm confident with and have another stab at the ones where things aren't quite working out for me. That way, you're going to maximize the marks you can possibly get.